Alright, so 7.5. This is the beginning of annuities. So this we're gonna start with the amount of an ordinary annuity. And I spelled the amount wrong. Amount of an ordinary annuity. Keep in mind this is ordinary, and I'll tell you what that means. So an annuity is a series of equal payments at regular intervals of time. So you say you keep investing $1,000 for 10 years every year. That's an annuity, and it's compounded. And so ordinary is referring to the fact that the money is invested at the end of every payment period, which is the time between payments, the regular intervals. And we generally assume the payment period is equal to the compounding period. So if you're paying every 6 months, it's compounded every 6 months. And the compounding period is referring to the interest that you earn. So the best way to represent this is a timeline. So let's start off with a basic example. So say for 10 years, so start at 0, and you go all the way to 10 years. 10. You have 10 years. And each year, you're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in every year, you're investing $1,000. So year 1 you invest 1,000, year 2 you invest 1,000, year 3 you invest 1,000, and so on. So year 8 1,000, year 9 1,000, and year 10 1,000. Okay, simple enough. And now we want to see how much of that money is compounded. So this $1,000 will earn interest for 9 years. So as soon as you put the $1,000 in, 9 years afterwards, so for the second year, the third year, the fourth year, the fifth year, the sixth year, the seventh year, the 8th year, the 9th year, and the 10th year, for those 9 years, this $1,000, say the interest is 0.5, 0.05 or 5%. This will earn interest equal to 1 plus 0.05 to the power of 9. This is basically saying it'll earn interest for 9 years. This is the interest that it'll earn. So for the second year, works the same way. It'll earn interest, which is 1 plus 0.05 for 8 years. The third year, the fourth year, the fifth year, the sixth year, seventh year, 8th year, 9th year. And so you can continue on. The third year will earn for 7 more years. And you get to the 8th year. And this will earn interest for 1 plus 0.05 to the power 2 years afterwards. This to the power 1. And this one finally will earn interest equal to 1.05. Well, because it'll earn interest for no more years to the power 0. This is basically gone. Equal to 1. And 1 times 1,000 is 1,000. So in the last year, this $1,000 will not earn interest. It'll just be the final payment he makes. So that's basically the timeline, and it'll help you to figure out the formula for compound interest. And basically, if you put this into a geometrical series and sub in A for the value and sub in all these numbers, this for n, and so on, the formula for compound interest is essentially for annuities is this: A, the amount, is equal to the R, or the amount you consistently invest, into 1 plus the interest rate This is dependent on the compounded quarterly, monthly, semi-annually that we talked about earlier. The power of n years also dependent on the compounding period, minus 1 divided by the interest rate, I. And so from this equation, you can do any question containing an annuity, unless we're finding present value, which we'll learn in the next unit. So let's try a simple question. We'll go into a hard one after this, just a knowledge and understanding question. So I'll write this one out and come back to you guys. Alright, so basically, let's follow through this example. This is a basic knowledge and understanding question. So you want to find the amount of the investment, the future value. So you basically have $15,000, which is the regular interval payment, 12 years, which is the compounding period, the full compounding period for n, and this is the interest rate. Because it's compound annual, you don't have to worry about dividing or multiplying anything. And so let's use the formula. Use a different color. R into 1 plus I to the power of n minus 1 over I. This is equal to 15,000 into 1 plus 0.142 to the power of 1 plus the power of 12 minus 1 all over I. And once you put this into your calculator, you'll get 414,118.19. And so that's your future value if you continually invest 15,000 for 12 years, compounded. Let's try a slightly harder question because this one was fairly straightforward. I'll write it down and get back to you guys. Alright, so here's a question. The Patel Academy, us, want to move into a bigger building to further develop the business. And the new building costs a huge $600,000 including tax. And so we want to save up money to earn the $600,000. So we're planning to invest money into an account that has an interest rate of 25% per annum, compounded monthly for 3 years. So how much money should we invest at regular intervals to raise the $600,000? Alright, so let's think about how to approach this question. We know the future value is $600,000. That's how much we need. We know the interest rate is 25% per annum. And we know it's compounded monthly. We know n is 3 years. And we want to find how much money we need to be invested, so R. Alright, so let's just plug everything into the equation first. So A equals R into 1 plus I power of n minus 1 over I. Now when we isolate for R, we'll get R equals to A times I divided by 1 plus I to the power of n minus 1. And now we just use the values we have. $600,000 times the interest rate, which is 25%. However, we should remember that it's compounded monthly. So this is actually 0.25 divided by 12. And this is all over 1 plus 0.25 divided by 12. to the power of n times 12, because there's 12 months in every compounding period. And n is equal to, as we said here, 3 years. 3. Let me show that in a different color. 3. And switch out the equation, minus 1. So once you do this, the answer will come out to be 11,363.20. So assuming we can make this much in a month, the Patel Academy must invest $11,363.20 per month for 3 years in order to achieve the $600,000. Alright, so and that's the end of ordinary compound annuities. Tomorrow we'll do present value, and that's it.